For my project, I did research about how planes fly. I learned about several cool topics, such as the 4 forces acting on a plane and the way planes generate lift. I learned that there is a widespread misconception regarding how planes generate lift. First, let's look at the 4 forces acting on a plane. Drag is the force that slows the plane down. It is caused by air resistance. Weight is the force that pulls the plane down. It is caused by the force of gravity pulling down on the mass of the plane. Thrust is the force that propels the plane forward. It is created by the jet engines. Lift is the force that keeps the plane in the air. There is a widely accepted misconception about how it is generated. It is widely taught that the air goes over the wing and meets up again with the air that went under the wing. They then misapply Bernoulli's principle, which states that a fluid at a higher velocity has lower pressure and vice versa. They say that since the air over the top goes a greater distance in the same amount of time, then the air over the top has a higher velocity and a lower pressure. The lift is attributed to this. However, this argument does not hold. Dr. Rubinski of Cambridge University did experiments to show that the air over the top goes so much faster than the air on the bottom, and the air on the top reaches the end of the wing well before the air on the bottom. If this isn't how lift is generated, then how is lift generated? Let's start at Newton's second law. Let's create a box. We'll fill it with Schrödinger's cat. Just joking. Let's fill the box with air. Since the 2 people pushing on the box have the same force, the box doesn't accelerate. When another person is added, the box starts to accelerate. Let's look at this in an example with streamlines. A streamline is a line along the flow of a moving fluid. When our box of air is floating along in mechanical equilibrium, meaning the net force is 0, there is no acceleration. When we add another person to the box accelerates. Let's take our box of air into the sky. But let's be realistic here. We can't have people in the sky, so let's put in ninja cats. Just kidding. Let's replace those ninja cats with a pressure gradient. In the sky, there are regions of varying pressure. These are pressure gradients. In this example, the pressure gradient goes from high pressure on the left side of the box to low pressure on the right side of the box. The higher pressure on the left side of the box creates a net force, which creates a net acceleration to the right. So when a pressure gradient is created with high pressure to low pressure, a net acceleration is created. When the pressure gradient goes from low pressure to high pressure, a net deceleration is created. How does this relate to lift? Because the airfoil is curved, it introduces a pressure gradient. This pressure gradient has the pressure increasing in the direction away from the center of curvature. Let's look at what happens when the streamlines go around an airfoil. We see 2 curved regions in the streamlines, one above the wing and one below the wing. As mentioned before, these curved regions contain a pressure gradient. These pressure gradients cause a change in velocity, so looking at this picture, we see that the top curve results in a lower pressure and therefore a higher velocity over the wing. The bottom curve results in a higher pressure below the wing. So we see that the curvatures that the airfoil introduces into the streamlines create the pressure differences needed for lift. A commonly asked question is, how do planes fly upside down? Let's flip our airfoil upside down and see what happens. Planes can fly upside down because they change their angle to maintain the curvature of the streamlines over the wing. As we can see, lift is not due to the air traveling further distances over the top of the wing. It is due to the curvature of the streamlines. It is important to note that this is a theory, and how planes generate lift is widely debated. This was the theory that I found most compelling. This is a subject in science that we thought we had figured out, but it turns out to be much more complex than we thought. This is an interesting topic worthy of more research.